Hello everyone. It's been longer since my last video than I initially hoped, but by now I have a few updates that I would like to share. These updates mainly concern the XY motion system, but then there's a few other points I would like to mention, and in the end have a short look at how the project might continue. For the XY motion system, there's mainly 3 points I would like to mention. First, the updated belt path, the redesigned gantry, and then the belt tensioning mechanism. With the previous version of the printer from last video, the 2 front motors would move forwards and backwards to tension the belts. Because the belt path now is a bit different, this does not work anymore. Or at least does not work as well anymore. So now I have this rotating mechanism. The idea behind the new belt tensioning system is quite simple. The motor now is directly attached to the base plate. And then there's this inner printer part which can rotate and is clamped to the base plate by the outer ring. And because this idler is attached to the rotating inner part, the belt can be tensioned in that way. While we are back here, let's also have a quick look at the end stops. For the y-axis, the end stop is quite traditional. For the x-axis, the end stop looks a bit different. Here, it makes contact with the heated bed. The initial reason why I went for this kind of 90 degrees turned design is because I did not have the space for the end stop. But in the end, I also like this design quite a lot because it is belt tensioned, so there's a spring in there that keeps the right angle together. And in this way, the heated bed can not only move until it activates the end stop, but it can also move a bit further than that. The idea is that with a regular end stop, the axis always has to be able to move a bit past the end stop in order to make sure that it can always trigger the end stop. In the end, this travel cannot be used while printing because you would run into the end stop. But with this design, when the end stop is kind of flexible, in theory you can use these 2 millimeters as well. But let's see how that goes. Because I like this idea a lot, I also want to implement it on the y-axis. Already printed the part for this, but I've not managed to install it yet. Let me quickly show you the end stops in action. Next, let's quickly take off the heated bed so we can have a closer look at what lies underneath. I hope it's well enough visible with the black belt on the black printer part, but like this we can have a look at the belt path. It's still basically a core XY system, but instead of this belt going around the outside to the other side of the gantry, it moves in the other direction and wraps around the other belt here before attaching to the gantry again. Compared to the previous version, this means that we have 2 lengths of belt more, which is not pretty. Also, there's a lot of belts here, which is also not very pretty. But I still prefer this design a lot because the torques are now equalized, because we have 3 belts here, 3 belts here, 1 belt and 1 belt on the other side. As you can see from the twisted belt holders, the torques here do not cancel out properly, but I'm hoping that the heat bed will be kind of strong enough to deal with this problem. In addition, the additional belt length I think is not that bad, because it's not between a motor and the gantry, but between the 2 motors. So in a 4-wheel drive configuration, I think this is not that bad. The only main downside for me is the additional mass at the gantry. It's a bit difficult to see here, but the gantry is a bit different now than it was in the previous video. Previously it was meant to be milled out of aluminium. Now it is meant to be 3D printed, which gives me more design freedom, which means that these attachment parts for the idlers are much more robust. And I'm hoping that using carbon-filled filament in addition to the rail that is screwed onto the gantry, this will be structurally sound enough. It's kind of hard to see from this perspective because everything is black, but like I said in the last video, I wanted to increase the radius, the bending radius, for the flat flexible cable that runs between the gantry and the heated bed. And I managed to do this by using this gap between this belt and the gantry. And the flexible cable now run in this gap. And for the other axis, the flexible cable is back here. All in all, I'm pretty happy how the XY motion system turned out, and I'm excited to see it in action. Since the last video, I spent a lot of time trying to figure out how to get the water block sealing against the 3D printer part. And the initial idea was to use O-rings for this purpose, but the downside of O-rings is that they need a flat surface to seal against, and 3D printed parts are notoriously not flat. So my idea was to use a acrylic sheet and glue it on top of the 3D printed part, but I was uncertain whether this would be watertight. I got kind of lost in the options. In the end, I went for what I think is the most reliable version, but also the version which is the hardest to take apart again, which is to simply take a lot of glue and glue the water block into the 3D printed part. I also made a test model for this. Let me quickly get it in front of the camera. So in this case, the water block is glued into the 3D printed part. For now, both parts are 3D printed and then sealed with Dichtol, as I showed you in the previous video. This test system has now been lying around for several weeks, so I'm pretty confident that it will be watertight in the end, and reliably so. Hi, future me here. At this point in the video, I wanted to include an outlook on the next steps in the project. However, since starting to make this video, a not insignificant amount of time has passed, and by now the printer looks quite a bit different. So stay tuned for the next video, where we will look at these changes as well as, hopefully, the first actual prints. But that's it for now. Thank you very much for watching.